Okay, hello everybody, and welcome to this quick, slightly updated video on the neuromuscular junction, and neuromuscular function as well, I guess. Um, Here we go. Here, um, this is where this is the motor end plate, where that neuron meets the muscle. Let's have a slightly closer look. There's a gap there. Um, so that gap is called the synapse. So we can see we've got the presynaptic membrane at the end of the neuron, and then on the muscle fiber we've got the postsynaptic membrane. So as the electrical charge travels down that axon, there's actually sodium going in and out there, but once it gets to the end, we've got some calcium that then enters into that presynaptic membrane. That tells these vesicles time to get going. So let's have a closer look again. Here we've got our calcium has come in. We can see these vesicles, which are full of acetylcholine. That calcium has told them it's time to get themselves across that that gap. So here's the ACH is acetylcholine, and there's the synapse that they've now jumped across. Um, so let's have a closer look. I hope that makes sense to you there. We've got the presynaptic, that's the motor, the membrane, if you like, that's the motor end plate. We've got the skeletal muscle down here, and the ACH is the acetylcholine that's now going across, making its way across. Actually, on the postsynaptic membrane, we've got these receptors, which are called nicotinic receptors. So that acetylcholine is going to make its way across, and it's going to attach to those receptors and tell them to open up. The acetylcholine doesn't actually go through, it just jumps across and tells the receptors they can open up. Can you remember what comes along next? We've got some sodium that comes along. And now that the acetylcholine has told these guys to open up, they can let the sodium through to the skeletal muscle. Bit more on that later, but for now we've now got this acetylcholinesterase to get rid of it. Anything that didn't, any of the acetylcholine that didn't get find a receptor to open up, gets eaten up by this stuff and taken away back to the motor end plate. That has all taken 1 millisecond, a ridiculously fast 1,000th of a second. So this is all happening super quick. Let's have a now look. We've got this sodium has made its way through into the skeletal muscle. What's it doing there? What's its purpose? Well, it needs to get deep into the muscle because we need to have all of the fibers, even deep within the muscle, firing, which is the ultimate aim here, is to get the muscle to contract. So it's going to go down the sodium down these T tubules, but next to, like attached to the T tubules, we have got the sarcoplasmic reticulum. What's inside the sarcoplasmic reticulum? Essentially, it's just a big storage unit for calcium. So we've got our calcium here, and as this sodium goes down, it's going to allow that calcium to release the calcium from the sarcoplasmic reticulum. There we go. Calcium's out and about deep within the muscle. Happy days, we're going to get a contraction pretty soon. Remember the cross-bridge cycle, this sliding filament theory, which we're going to go on to look at now. We've got the myosin, which is thick, and we've got the actin, which is thin. The actin is thin. Let's take a closer look at that again. Remember, we spoke about these myosin heads touching, but let's take them away for now because actually the actin is locked up. Those myosin heads can't get in there yet because we've got tropomyosin that's wound around the actin, and it's locked up with some troponin. So along comes the calcium, binds to that troponin, and that gives the signal for the tropomyosin and troponin to get out of there. This allows the myosin heads to then connect with the actin. And now we've got that power stroke. We've got the ATP coming in. We've got the ATP, remember, binds with those myosin heads. You'll see there's flashing down the bottom. I went back there. You'll see these are quotes from mark schemes that you're seeing down the bottom. So feel free to pause and read that and make sure that that's making sense. The ATP has attached to the myosin heads. It's allowed them to then release. It's released that energy, creating ADP and those phosphates, and that energy allows the myosin head to go back and grab that actin again. So it's a little bit confusing because normally we'd think the ATP causes that actual power stroke, but the myosin heads deal with that. The energy gets the myosin heads back to where they started again. The energy, remember, so that gun's there because that's called the cocked position. The energy also, remember, takes calcium ions and puts them back to that sarcoplasmic reticulum to be recycled and used again for another contraction. Off they go to the sarcoplasmic reticulum. So here are some mark schemes from questions that you may be asked. I'll let you pause this and look at them in your own time. Lysis, remember, is to break down. Have a look at them in your own time and see that you understand that. Hope that's been useful to you.